Welcome students. Today our topic is construction of overhead distribution lines. This topic is very important as for the field survey and including the construction of overhead lines. Now, an overhead power line is a structure used in electric power transmission and distribution to transmit electrical energy across large distances. It consists of one or more electrical conductor suspended by tower or poles. Since most of the insulation is provided by surrounding air, overhead power lines are generally the least costly method of power transmission for large quantity of electrical or electricity energy. Now, when we talk about the construction of this structure, the first thing which is striking in our mind that we are using that towers, or we can say that the support structure for the conductors. Then we are already studied or already discussed about the towers and the various type of steel towers, steel lattice tower, poles. The tower for support of the line are made of wood, either grown or laminated steel or aluminum, concrete, and occasionally reinforced plastics. The bare wire conductor on the line are generally made of aluminum with steel or composite material such as carbon and glass fibers. Now, a major goal of overhead power line design is to maintain adequate clearance between energized conductor and the ground so as to prevent dangerous contact with the line and to provide reliable support for the conductor, resilience to storm, ice load, earthquake, and other potential damage which are occurs. Now, when we classified our transmission line, we are classified as per by the operating voltage. Overhead power transmission line are classified in electrical power industry by the range of voltages. Now, we are categorized into three categories, that is the low voltage LV, which is less than 1000 volt, used for connection between a residential or a small commercial consumer and the utilities. Medium voltages, in short we call MV, it is also a distribution line. It is between 1000 volt or 1 kV and 69 kV, used for distribution in urban and rural areas. And the last is high voltages, it is also called the HV. It is a sub transmission less than 1000 kV, sub transmission or transmission at voltage such as 115 kV and 138 kV, used for sub transmission and transmission of bulk quantities of electric power and connection to a very large consumers. Now, also we have that extra high voltages, which is around from 345 kV up to about 800 kV, used for long distances, and it is a very high power transmission. And we have also have a ultra high voltage, is higher than 800 kV. Now, another we are classified by the length of the line. We are classified as per the length. It is into three categories, that is small transmission line, medium transmission line, and the long transmission line. Now, when we talk about the transmission line, or we are going to erect our transmission line, the survey is the most important activity in this part. And after the survey has to be done, we have to find out the best suitable route for the transmission line, and also we have to check the right of the way. And the techno-economical project, we have to consider this point also, and the timely completion of the project, in how much time or in how much duration we are completing this project, and the increasing demand, because the demand is increasing day by day. Now, when we preliminary survey and the walkover survey, we are talking about that. First, we are see that the topographical map, or in short we call it topo maps, and the second point is the B line. Then identify possible routes, familiarize, and indicate the feasible routes. These 5 points we have to consider for the preliminary survey. Now, when we talk about the topography map, topography concerns the shape and character of the earth surface, and map were among the first artifacts to record these observations. These are also known as topographical map. In modern mapping, a topographic map or topographic sheet is a type of map characterized by large scale, detail and quantitative representation of relief, usually using contour lines, but historical using a variety of methods. Traditional definition require a topographic map to show both natural and artificial feature. A topographic survey is typically based upon systematic observation and published as a map series made up of two or more map sheets that combine to form the whole map. A topographic map series use a common specification that includes the range of cartographic symbol employed as well as the standard geodetic framework that define the map projection. In short, we can say that the topographic map, despite electric ground relief, drainage, forest cover, administrative area, populated area, transport route and facilities and other man-made feature, these all things are shown on the topographic map. Now, we have the topographic map of a small area that we have the you can see it is clearly that it is a topographic map of the Andhra Pradesh. Now, suppose we have to install a substation in that particular area. So we have to identify the spots in that place. So like here. So we have to install a substation between here to here. So it is a sending end substation and it is a receiving end substation. So first of all, what we do, we put a straight line between these 2 points. So this line is called the B line, B-double-E line. B line is called. And after that, when we are going for the survey, then we find that there is a pond is there, there is a small lake is there, there is a mountain is there, small hilly part is there, there is a farm is there. So as per that, the original line will be deviate from that B line, and it will be after the deviation it will be get to the receiving end substation, and throughout the line we just marking where we are aligned, and we put the poles throughout the line. Now, for the preliminary survey and walkover survey, what we have to find the shortest possible route we have to find, and we focus on the less number of deviation. If the deviation is there, the more number of supporting structure is required, and the overall the capital cost of our project is increased. So the less number of deviation is required and the shortest possible route is followed, then our cost will be minimum. Now for the detailed survey or the tools which we are required is a theodolite and ranging tools, dumpy level and measuring staffs, measuring chain and the megger. These are the tools. By this we are doing our detailed survey, and for this detailed survey what we have to focusing on the points are the fixing of the alignment, fixing of line points, fixing of angle of deviations where our line is deviating, fixing of angle points, fixing of direction points, measuring of distance between angle points, and level at every 10-meter interval or where there is a level difference of 30 centimeters. So we have to consider all these points and we have to fixing these points also. Now also we have to discussing that detail of roads, detail of village, PNT line crossing, all tower line crossing, if there is a transmission line is already there, so we have to consider where is a line crossing is there, and we have to check out the railway crossing, river crossing, agricultural well, field burns, earth burns, etc., measuring soil resistivity and trial pits, crop and tree enumeration. We have to consider this point also because we have to take a prior permission to erect a line. When the railway crossing is there, we have to take a prior permission from the railway department. If the river is there, we have to consider from the take a prior permission from the considerable department. Now the obligatory point is that we have to what we think we have to avoid, and the reserve forest area we have to avoid that reserve forest area also, that military firing range we have to avoid, aerodromes we have to avoid, inhabited and thickly populated area we have to avoid, and hilly terrain we have to avoid, marshy, low lying and submersible area we have to avoid, because it has very less chances that it will be sustained, our tower will be sustained there, that kind of land. And oil and gas storage area we have to avoid, these area we have to avoid. Now the detailed corridors for that, the 132 kV corridor is 27 meters, 220 kV is 35 meters, and 400 kV line is 52 meters. Now the line profile is that indicate all power line crossing, that low line to 765 kV, indicate all PNT line crossing, indicate all railway crossing. We have to mark that these things, that indicate all river crossing, indicate all roads, cart tracks or national highway, indicate all villages, indicate all agriculture wells, indicate all field and earthburns, indicate all boundaries, indicate all ponds and lakes, indicate which type of soil as per their, and indicate crops and tree as per the location. Now when we have going for the tower spotting, we have to identify the position of the terminal tower, and we have to start from the terminal tower, match the tower footing curve with the position, adjust the position of template, ensure ground clearance, identify the position of next tower, move the template to next tower, and repeat this procedure till our project is not completed. Now for the tower, we have to find out what is the normal span. It is the design span. Actual span, it is the actual distance between the two adjacent tower, and the null point, it is the point in a span where the position of the conductor is lowest. It is a point in a span where the sag is maximum, and the weight of the span, the distance between two adjacent, or we can say null point, and the wind span, it is the distance between the two center point of the adjacent span. That's all for today. The remaining part of this construction over design we are discussing in next class.